birds, have long captivated humans, with their ability to navigate at high speeds through cluttered environments, while maintaining remarkably low failure rates. Similarly, micro-air vehicles, among the most agile machines created by humans, hold the potential to achieve bird-like agile flights. While human experts can replicate bird-like agility, balancing high speed and safety in autonomous flights remains a challenge. Current approaches often sacrifice safety for speed, or vice versa. This raises a critical question. How can autonomous MAVs achieve both high speed and safe flights in unknown real-world environments? Introducing Super, a safety-assured high-speed aerial robot. Super is compact with a wheelbase of just 280 millimeters and a takeoff weight of 1.5 kilograms, achieving a thrust-to-weight ratio greater than 5.0. It is equipped with a 360-degree light detection and ranging sensor, capable of detecting objects up to 70 meters away, at a point rate exceeding 200,000 Hz. With advanced LiDAR-based perception, safety-assured planning, and optimal control modules, Super navigates unknown environments at speeds over 20 meters per second, relying entirely on onboard sensing and computation. It can maneuver nimbly through extremely cluttered environments at high speeds, without compromising safety. With its advanced LiDAR-based perception system, Super can efficiently detect and avoid thin obstacles such as power lines. Moreover, it can identify thin objects less than 2.5 millimeters in just 20 milliseconds, enabling precise navigation through challenging environments that pose significant difficulties for state-of-the-art vision-based commercial products. The active detection mechanism of the LiDAR also enables Super to operate all day around, even in total darkness. Thanks to these exceptional capabilities, Super has been tested across various real-world applications. It can be applied to autonomously explore ancient sites, seamlessly navigating both indoor and outdoor spaces. It can also traverse dense forests with safety guarantees, overcoming complex obstacles. Super's agility extends to object tracking missions, allowing it to closely follow targets and avoid obstacles in both indoor and outdoor environments, during both day and night. With its high-speed navigation abilities, safety-assured design, and robust performance, Super marks a significant milestone in transitioning high-speed autonomous navigation from the laboratory to real-world applications. Although not perfect, researchers hope Super will unlock new possibilities in future real-world scenarios, such as autonomous delivery, inspection, mapping, and search and rescue missions.